This equation that you are watching on your screen is called the God equation, and today we are going to see how it reveals all the secrets of this universe. Maybe we can create a new universe after learning the secrets of God and knowing His ingenious mathematics behind its creation. So without any further delay, let's get straight into it. The mind of God, which Einstein wrote eloquently about, is cosmic music resonating throughout hyperspace, as Michio Kaku describes. What is the mind of God and how does it work? The same principles Albert Einstein has followed nearly 30 years of his extraordinary life. Albert Einstein wanted a single equation that could combine all the forces of the universe, an equation that contained all the combinations of all the forces of nature and the universe. These forces are gravity, electromagnetic force, weak nuclear power, and strong nuclear power. If you have a deep understanding of the laws of physics, then you know what's possible, what's reasonable, and what's impossible. And that's how the physical foundations make all the difference in the world. All biology can be explained in the language of chemistry. All chemistry can be explained in the language of physics. But all physics can be explained in the language of relativity, like the Big Bang and quantum theory that gave us transistors, lasers, and the internet. The goal is to combine these two great theories into one 2.5 centimeter or 1 inch long equation that allows us to uncover the universe itself, the Holy Grail that we can call the Holy Grail of science. The problem is that quantum theory doesn't fit into general relativity. See what I mean is that Albert Einstein's theory of general relativity is based on smooth surfaces. Quantum theory is based on the breaking of matter into particles, which is the opposite of Einstein's philosophy of smooth curves representing space and time. That's why it is so hard to reconcile these greatest concepts in physics. So far, we can say that there is only one theory that has survived every challenge, string theory, also known as the theory of everything. What is string theory in physics? String theory is a theoretical framework that replaces point-like particles in particle physics with one-dimensional objects called strings. String theory explains how these strings propagate in space and interact with each other. It replaces all the fundamental particles with a single element, vibrating strings, a dancing filament of energy that looks like a vibrating string. They do not produce musical notes through their vibrations, but produce different fundamental particles through their vibrations. These strings produce all kinds of particles, including matter particles, electron, proton, etc., as well as radiation particles, photons. These are the fundamental elements of everything, the tiny, indivisible, uncountable constituents of particles making up everything in the universe. Is this making any sense to you? If not, don't worry. Let me elaborate on it using the story of dimensions. After listening to this story, I'm confident that by the end of this video, you will be able to connect the dots of string theory. So let's start from the beginning. In 1919, Theodor Kaluza, a German mathematician, presented a very bold idea of the KK theory. He proposed more than 3 dimensions for our universe, which, for some reason, we still haven't seen. In addition to length, width, and height, Kaluza offers other dimensions. This idea had a great impact on physics over the last century. Please keep this idea in your head as we're going to link back to it. 1907 is the year when Einstein is bathing in the glow of discovering the theory of relativity and decides to take on a new project to try to understand fully the grand force of gravity. Though Newton already gave the theory of gravity in the late 1600s, the motion of the planet, the motion of the moon around the Earth, and the motion of the apple around the tree, and all that can be described using his work, Einstein realized that Newton had something left in the story. Because even Newton had written that though he understood how to calculate the effect of gravity, he was unable to figure out how it worked. So how does the sun, at 93 million miles away, affect the motion of the Earth? How does it exert its influence? And that was the task that Einstein assigned himself, to figure out exactly how gravity worked. So let me show you what Einstein found. He found that the medium that transmits gravity is space itself. The idea is that imagine space as a flat fabric or cloth, if there is no matter present over it. But if we place a mass, such as the sun, it would make the fabric curve or wrap, and that communicates the force of gravity. Even the Earth influences it through the same concept. Now this idea was tested in 1919 through astronomical observations. It really works. It provides data, and this gained Einstein prominence around the world. And that was what got Kaluza thinking. He was also in search of the unified theory like Einstein. the one theory that might be able to describe all natural forces through one master equation. He said Einstein described gravity in the form of warps and curves. Maybe other natural forces, like electromagnetic force, could also be described by playing the same game with them. That raised the question, warps and curves in what? Einstein had already used space and time warps and curves to describe gravity. Kaluza said, maybe there are more dimensions of space. He said, if I want to describe one more force, maybe I need one more dimension. So he imagined the fourth dimension in space and imagined those warps and curves in that dimension. Now, here's the thing. When he wrote down the equation of warps and curves in that fourth dimension, he found all equations that Einstein had already derived in three dimensions, those for gravity. But he found one more equation due to one more dimension, and it was none other than the equation of electromagnetic force. Amazing! It was popped out. He was so excited by this realization that he ran around his house screaming victory that he had found the unified theory. Now, in practical sense, two questions immediately arise from his observations. Number one, if there are more than three dimensions, then where are they since we don't see them? Number two, does it really work in detail when you're trying to relate the real world around us? Let's start with the answer to the first question. The first question was answered in 1926. That was dimensions may come in two varieties. They might be big and easy to see, but they may also be so small to be seen. Those tiny dimensions may be around us, but are so curled up and tiny that we are unable to see them. To visualize it, imagine a wire on a street light. Through some distance, it looks only one-dimensional, that is length. But if you zoom in, you'll see its thickness, and an ant can even move around it clockwise or anticlockwise. An ant is so small that it can access all the dimensions. And this emphasizes that dimensions can be of two sizes, big and small. The idea is that the big dimensions around us that we can see, but there are tiny, curled-up dimensions that we cannot see, and they're so far invisible. If we had a look at space itself through an ultramicroscope and weigh down in the microscopic depth of the space, there will be dimensions so small they are curled up like some sort of circles and curves of that wire. This is the idea of additional dimensions that we cannot see with the naked eye or even with the most precise equipment. But those dimensions are tucked up in the space-time fabric. Now, that is the explanation to how could the universe have more dimensions. Now, coming to the second question. Does it really work when you try to apply it to the world around us? Well, many physicists, including Einstein and Kaluza, and many others, try to refine the idea of this framework to apply to the real world and physics of the universe, to the physics that was understood at the time. And it did not work in detail. They did not find the mass of the electron using this theory. The new approach to unified laws of physics, superstring theory, many scientists worked on it till the late 40s and 50s, but it did not work. And this idea of unified theory had gone away until something wonderful happened in our age and our era. A new approach to getting the unified laws of physics is being preceded by many physicists, such as Brian Greene. It's called superstring theory. And the wonderful thing is that the superstring theory has nothing to do with the idea of extra dimensions. But when we study string theory, we see that the idea of extra dimensions is sparkling in a form. So, let us have a look at the idea of string theory. It is the theory that works on finding the smallest uncuttable fundamental particles making up everything in the world around us. The idea is like this. So imagine a candle on a holder, and imagine that we want to figure out what its fundamental constituents are. So deep down, you all know we have atoms, and atoms are not the end of the story. Then comes electrons, a nucleus made up of protons and neutrons. Even here is not the end. We also know that they are made up of quarks. And here conventional idea stops. Here's the new idea of string theory, that in deep inside of these particles, there is something else. And that something else is the dancing filament of energy that looks like a vibrating string, which is the idea from where string theory comes. And different energies of different frequencies of strings produce different particles. The universe is built up of a huge number of these tiny vibrating strings. And here you see the unification because matter particles, I, quarks and electrons, radiation particles, I, photons and gravitons, are also built up from one entity. So matter and all forces of nature are standing under the same roof of vibrating string. And that's what we mean by unified theory. And here's the catch. When you study the mathematics of string theory, you will see it just doesn't work in the world of 3 dimensions in space. It does not work with the universe with 4 dimensions in the space, nor with 5, nor 6. Finally, when you study these equations, and you'll see that string theory only works in the universe with 10 dimensions of space and 1 dimension of time. Here we go back to what Kaluza also said and suggested, more than 3 dimensions. So, are you now able to connect the dots back? Here's a question. Do these dimensions hide away or tell us something about the universe? Well, many physicists believe that what string theory will provide answers to is perhaps the deepest question in theoretical physics. And that question is, when we look around the world as a scientist, there are really 20 numbers that describe our universe. These are the numbers like the mass of the electron, proton, quarks, the strength of gravity, the strength of the electromagnetic force, and the list has 20 numbers that have been measured with incredible precision. But nobody has any explanation that why these numbers have these particular values that they do. Now, the string theory doesn't answer our question yet, but we believe that the answer relies on the form of the number of the dimension. And the wonderful thing is that if those numbers have any other value than they have, the universe would not exist. This is the deepest question, that why those numbers are so finely tuned, and what will happen if we fiddle with those numbers. Fiddling with those numbers makes the universe disappear. So, can we explain those 20 numbers? String theory suggests that these 20 numbers have to do with the actual dimensions strings vibrate in the allowed vibrational patterns. And if we could calculate those vibrational patterns, we should be able to calculate those 20 numbers. And if the answer that we get from our calculations agrees with the value of those numbers that have been determined through detailed and precise experimentation, this in many ways would be the first fundamental explanation of the structure of the universe, the way it is.